All right, so today is 2.4. We talked about tangent ratio in the last few sections. We're going to talk today about the sine and cosine ratio. So when we talk about trigonometry, there's three primary trigonometric functions. One is tan. The other two are sine and cosine. Well, you've probably seen these before, grade 9. Last year, we talked a little bit about this. But let's talk about what those ratios mean and how they are connected. So there's a little bit of a story in your textbook here. So the railroad track through the mountains between Field, BC and Hector, BC includes spiral tunnels. They were built in the early 1900s to reduce the angle of inclination of the track between the two towns. So these are mountain towns in BC. And obviously, if you took a direct route, it would be quite a steep, quite a change in the altitude. And trains can't do steep. So they went back and forth, kind of a spiral through the tunnel, through tunnels and different things, to reduce the inclination of the track. Visualize the track straightened out to form the hypotenuse of a right triangle. So in reality, it's not like this, but we could stretch it out and draw it that we have a town here and a town up here, and the track itself, being 6.6 kilometers, covers an overall difference in elevation of 297 meters. So I have this up in the notes here, so let's take a look at this. So if you want to just take a moment to sketch that triangle, we're going to work with this. And you see that we're given an angle, or we're asked to find an angle, looks like here. And we're given the opposite side, and we're given the hypotenuse of a right triangle. And so the question here is, how do we determine this angle right here? This angle of inclination is very small, but how could we determine that? Well, we have used the tan ratio so far. We've used the tan ratio, but the tan ratio, if you remember, it is opposite divided by adjacent side of a right triangle. So if this is the angle right here, the opposite is given, but the adjacent side is not given. Okay. We could find that adjacent side, right, using Pythagoras. A squared plus b squared equals c squared. So we could solve for that. But to cut down on some of the work, there are other trigonometric ratios other than tan that we could use to find angle measures. And they are sine and cosine. And so I think I mentioned this to you last week, but do you remember this memory mnemonic, SOHCAHTOA? Have you guys heard that before this class with me, like before this semester? No, this is the first you've heard of it? Okay. So SOHCAHTOA refers to the three primary trig ratios. Tan we've already studied. And we learned that TOA means opposite side of the angle divided by the adjacent sides of the angle gives us the tangent ratio. Well, we also now have sine for S and cosine is C. And these sides over here, the SO, OH, and the AH, refer to the sides of the right triangle. So to this angle right here, this is the adjacent side right here. This is the opposite side, and this is the hypotenuse. So think about your right triangle diagram. And so, similar to the tangent ratio, we now have sine of an angle, and remember that the symbol for an angle that we often use in math is theta, the Greek letter theta. So the sine of an angle, that ratio is given by O over H, or opposite side divided by the hypotenuse of the right triangle. And C is for the cosine. So the cos of angle theta is the adjacent side, that's A divided by H, or hypotenuse. And just to round it out, that we've already studied, the tan is opposite divided by adjacent. Okay? All right, so these are the other two of the three primary trig ratios. Primary means the most important, the first prima. Then the trig ratios, there are three. Okay, now there are more trig ratios, but we won't talk about those, I don't think, in this course. I think we save that for our next course. But solving for the angles and solving for missing pieces of each of these proportions that we see here is exactly the same as with the tan. And notice on your calculator, all right, so I don't know my little applet up there yet, but your calculator here, you have the sine, cos, and tan buttons. And so just like we did second function tan to get the angle, remember that? We're going to do second function sine and second function cosine. So if you look at this, what are we given? Without doing Pythagoras, we are given opposite and hypotenuse. So which of these three include opposite and hypotenuse? It is sine. Okay, now it's not sin, it's sine. It is abbreviated sin, which is the word sin, but it is sine. So we're not going to say sin theta, we're not going to say cos theta, we're going to say sine theta and cos theta, okay? Again, it's just, this is the convention in math, so if you say cos theta, it'll sound like you don't know what you're talking about, okay? Sin theta, it's sine theta, all right? So I'm just trying to help you out here, okay? I would hate for you to mention, cos theta at a party or something, and then have all your friends, shun you. Like, oh, I don't even know what cosine is. Okay, that would be tragic, right? Okay. Anyways, I'm sure none of you are worried about that. Okay, so I have opposite and hypotenuse, so I'm going to go sine. Watch this. Sine of theta. The angle is unknown, so I'm going to leave my variable there, my theta variable, but I am going to fill in the other parts. So opposite is 297, and the hypotenuse, Can I just write 6.6, or is that going to be a problem? It's going to be a problem. These numbers that we use in these ratios here, proportions, have to be the same unit. So can you quickly and easily, from your work in chapter 1, can you quickly and easily transform kilometers to meters? Remember how to do that? How do we do that? Times by 1,000. Very good. So this is actually equal to 6600 meters, right? 6,600. Okay, awesome. So let's make sure we catch that. 6,600 or 6,600. Now we've got this right, because this is a seriously long track, right? It's a long train track. Okay, well, in order to find the angle, yes, the same thing as what we did before. This is a bit of a repeat lesson here, I think, really. It's just we're using sine to the -1 instead of tan to the -1, or inverse sine. That eliminates the sine. Sine to the -1 eliminates sine to the +1. Think about that. And so we want to calculate this on our calculator. Okay? So go ahead, make sure you know how your calculator works. Some of you have to put in, shift sine first and then put in the ratio. That's what I'm going to do. 297 divided by 6600. So sine to the -1 of that ratio on my calculator. And you got to make sure you're in degrees. If you have a big fat D on your screen, or DEG, make sure you have that, please. So I get theta equals 2.58, if I round it to second decimal place there. And that would be in degrees. So 2.5 degrees. That seems very, very small, doesn't it? You think about a train, though. You think a train carries so much weight, right? Like 100 cars full of stuff. So it can't go uphill very much at all. There's a minimum angle of inclination there. Okay, so how's that look? Does that seem about right? How could we check that? Well, let's try sine of this value, 2.5, and the decimals are 79181. Good to use all the decimals in your check if you can. That should equal this ratio of 297 over 6600. So let's just see. Sine of, and I'm going to just put my full answer in there, sine of that big long decimal is 0.045, and 297 divided by 6600 is 0.045. So they are exactly the same, so this is the correct answer. Okay, any questions about that? Anybody? Pretty easy? It's very similar to the previous lesson on tan, isn't it? Yeah, I mean, it's just a different button on your calculator, doing everything the same. Okay, I copied this from the textbook. I do want you to, you don't have to maybe label it with all the letters, but do label the numbers for sure. first. Do that first, and then we'll get to the letters. I just want to show you a couple things, okay, about the tan ratios. And this is something just to help confirm that different size triangles or different numbers in the ratio will still be can still be attached to the same angle. So these are, and what you want to notice here, these are 1, 2, 3, 4 triangles nested into each other. So here's one triangle right here. I'll use my highlighter. This is the 3, 4, 5 triangle. See that? That's one triangle. Now nested into that, so that means that this second triangle also shares this angle of inclination. Nested into it is this triangle that has a base of 8 and a height of 6 and a hypotenuse of 10. You see that? 5 and 5. And so we have all these triangles that are nested into one another. Okay? That means that angle A is the same for all of these triangles. Okay? So if I were to take a look at the sine of A, and I were to use my small triangle, okay, the small triangle, and the opposite side to A is 3, and the hypotenuse for this small triangle is 5. So 3 over 5. Well, what is the what's for the bigger triangle, not the next size up, what is the sine of A? What's that ratio? Well, that ratio is going to be, for A, opposite 6 over 10. 6 over 10. Now notice that this reduces to 3 over 5. So same angle, and we have similar triangles nested in one another. Okay, so all right angles at the bottom here. I'm going to skip now to the largest possible triangle that we have here, this one here. And let's do the cosine. Let's do the cosine. So of the large triangle, let's do the cosine. Well, the cosine of A, I'll do that down the bottom here. The cosine of A is going to be, what is it? Ka. So, ka toa. Right. So cosine is adjacent over hypotenuse. Well, for the large triangle, the adjacent side is the sum of all of these. 4 plus 4 plus 4 plus 4. That's 16, isn't it? Okay. And then divided by the hypotenuse. 5, 5, 5, 5. What's that? 20? 20. So that reduces to, what? 8 over 10 reduces again further to 4 over 5. Okay. Now let's go back for the cosine for the small triangle. Let's fill this in. Small triangle. Cos of A for the small triangle is adjacent divided by hypotenuse. Oh my. Look at this. 4 over 5. Okay? So as you just kind of let this sink in a little bit, the reason why I want to show you this, and I could have showed you this the first section, but the reason why I want to show you this is because that it doesn't really matter the size of the triangle. If the angle is the same for a small triangle, right triangle, or a large right triangle, the ratios of the sides will also be the same. Okay? So think about it. If you have a small triangle and you extend the base, you also have to extend the hypotenuse, and the opposite side has to get bigger as well. So everything grows or everything shrinks kind of at the same rate. So this is just another way of looking at that these ratios, it doesn't matter the size of the triangle, the ratios are just ratios of sides. Okay? And if they're similar triangles, that means they have this angle is the same, this angle is the same, that means they're similar, then they will have the same ratios. Okay? Okay. So, any questions about that? Okay, so just to sum up what we've said here so far about the new sine and cosine ratio, again, I will put SOHCAHTOA up here. SOHCAHTOA. Very, very important. Easy to remember what's what. The sine ratio, S, sine, is the length of the opposite side to the angle divided by the length of the hypotenuse. Sine equals opposite divided by hypotenuse. The cosine ratio for an angle, angle A, C, is the adjacent side divided by hypotenuse. That's cosine of an angle equals adjacent divided by hypotenuse. And if this is our angle A, please remember that the side opposite of A, strike a line right through angle A, and the side that it hits is opposite. The adjacent side is the side that forms angle A, the side right beside angle A that is not the hypotenuse. So opposite and hypotenuse are the first easy ones to identify, and then adjacent is the third one. Okay? SOHCAHTOA. All right, do you understand this? 1 is you do not understand this at all, like very minimum. 5 is, this is pretty easy. I could explain this to a friend that was missing today. Where are we at here? How many fingers do we have? I'm looking around the room. Show me fingers, okay. I'm seeing a lot of fingers, okay. I'm not sure what this is. What's this? What is this? It's like, depends on the minute. Okay, all right. Okay, good. A lot of fingers. So this is easy for you guys, seemingly. I like it. I like it a lot. I mentioned this before, primary trig ratios, okay? Primary trig ratios are the sine, cos, and tan. Sine, cosine, tangent. Sine, cos, tan. Those are the primary trig ratios. The word trigonometry is, there's 3 parts to it. Comes from Greek words trigonia and metron. So that is three-angle measure. And the branch of math that deals with the relations between sides and angles of triangles is called trigonometry. And I've mentioned that word before as well. So if you're interested in writing this down, you can. Trigonometry, there's the 3 parts of the word, Greek words, and it describes relations of sides and angles of triangles. So triangles, trigonometry, the primary trig ratios are what you should remember there. All right, so we'll do this question here. We'll do this question. I think that might be all that I probably need to do for you before I let you off in your assignment. But here's a question where you have a right triangle, and you're given the ratio of the sine ratio. So sine of A equals 0.5. All right. So the ratio between the opposite, so the opposite side and the hypotenuse, is 0.5. Sine of A is opposite of hypotenuse is 0.5. Or 0.5 over 1. Okay, so the sine of angle A, sine of A is made up of opposite side over hypotenuse. The sine of A equals 0.5, so opposite over hypotenuse equals 0.5. If you make this a ratio, what you see here is that the opposite side is always half of the hypotenuse in this case. Okay, so this side is 0.5 times this side. All right, relation between angles. So the question is, if sine of A equals 0.5, and let's say that in this question I'm going to ask you here, here's A, this is 13, and I don't know what this side is. Okay. So you know that the ratio is 0.5, and this obviously is smaller than this one, so you know what x is. But if you didn't know this little memory thing, right, like if you didn't kind of see that, you're like, okay, how do I do this? Well, you go 0.5 equals opposite 13 over hypotenuse x, right? Because sine of A equals opposite side over hypotenuse. So 0.5 is what the sine A equals, 13 over x. Multiply both sides by x, you get 0.5 x equals 13. Divide both sides by 0.5, and x here then equals 13 divided by 0.5. When you divide by decimal, between 0 and 1, the number gets bigger. So that's the same as multiplying by 2. So this is 26. Okay, so the sine ratio is equal to the ratio of the opposite over hypotenuse. Questions? All right, so question in your assignment gives us this right here, and it says in each triangle below, name the side opposite A, opposite of angle A, name the side adjacent to angle A, and name the hypotenuse. Notice the hypotenuse is not really related to one of the angles, it's just always opposite the 90 degree. So that's opposite the 90 degree angle, right? So let's do this together. So for 1, the side opposite to angle A is the side, now I'm going to not use the length here, I'm going to name the side, so that's the side GH. GH. Okay. The side adjacent, okay, so that's opposite. Adjacent to A, careful now, it's not this one over here because that's opposite the 90, so the side adjacent is GA. Adjacent to angle A. And the hypotenuse is, however you want to put that, HA is hypotenuse. B, for first one here, for each triangle in part A, determine the sine A and cos A to the nearest 100th. All right, so here we go. Now we get to use our calculator. So sine of A is made up when you divide the opposite side divided by the hypotenuse. So the sine of A is 3 over 5, or as a decimal, what's that? 0. 0 point what? Yep, it's 0.6. Okay, so there you go. Sine of A is 0.6. Cos of A is, let's see, adjacent over hypotenuse, right? Ka, so ka toa, so adjacent over hypotenuse. 8 over 10, that's 4 over 5, which is 0.8. Okay. All right, how are we feeling about that? 5 out of 5? Or thumbs up? Okay. All right. Okay, why don't you guys do 4A2? Do 4A2, and I'll put those answers up. Do 4A2 right now with this triangle. Okay, we can go ahead and look up on the board there to see the answers. Hopefully you've gotten that. Okay, so I'm just working on your homework. The assess your understanding is not required. So this is 2.4 we did today, right? Yeah. Okay, so there's your assignment as well. So I'll just go over this here and show you that.